Welcome. Today let's try to solve another Leetcode problem, 651, 4-case keyboard. So this is a popular problem for Leetcode. So we are having 4 cases. We have A, Control C, and Control V. So when we press A, we're gonna have a letter capital A on the screen. Or we can choose another solution. We can press Ctrl A and Ctrl C, and after that we're gonna have a buffer. Then we're gonna press the Ctrl V. So after that, print the buffer on the screen. So this means if there has already been an A, so after these 3 combinations, we're gonna have another A. So if there are 2 A's, so we're gonna have another 2 A's. It means in total we're gonna have 4 A's. So this is just the normal case, like did we do our daily work. We always use Ctrl A, Ctrl C, and Ctrl V. It's exactly the same. So we need to return the maximum number. If we have n, it means we have n operations. So we need to return the maximum of a's. So for n equals to 3, so the maximum is 3. When n equals to 7, so the maximum is 9. Why? Because we can press 3 times of A. After that, we're gonna choose a combination of Ctrl A, Ctrl C, and Ctrl V. So after this way, we're gonna have 6 A's. And we can continue, press a Ctrl V. So we're gonna have a 9 A's. So we're gonna return a 9. So the value of n is 1 to 15. So for this problem, normally we're gonna use dynamic programming to solve the problem. So let me first go to the whiteboard to explain my solution. After that, I go to the code editor to finish the coding. So this is some drawing I did a few minutes ago for our problems. So because for our problems, when this n equals to 1, when n equals to 1, and the result is 1, so I'm gonna use a function to represent. So fn, so here this fn gonna be f1 equals to 1. This is according to our problems, and f2 equals to 2. Etc. And f7 equals to 9. And I'm going to prepare a DP array. So this is f7 equals to 9. So this is according to the description. It told us f1 equals to 1, f2 equals 2. So if we press 7 times, we're gonna have a 9. So this 9 is according to, we're gonna press 3 A's first, and then we're gonna use a combination, Ctrl A, Ctrl C, and Ctrl V. We're gonna have another 3 A's, and then we're gonna use a Ctrl V, another 3 A's. So in total, it's gonna be 9. So for our DP array, so this is the DP array. So the DPI means the maximum of A's we can get. And this is the index I. So I will from 0 to 7. So for I equal to 0, it means we didn't do anything. So the result gonna be 0. When I press 1 time for I equal to 1, so my result is 1. So this is for if I didn't think about the Ctrl A, Ctrl C, and Ctrl V, didn't consider about the this kind of other 3 cases. I only consider if I can only press A. I will not press others. If I can only press A, so what I can get. So if I press 1 time, I get so the DPI should equal DP1 should equal to 1, DP2 equal to 2. It means if I press 7 times, if I only press A, I'm gonna have a 7. So this is I will only consider press the A. Another situation is we can also choose a combination of press. It means we will press Control with A, C, V. So this is a combination, I will use this circle to represent another plus. So another plus is plus control here with a C. With control A, control C, and control V. So this will actually consume 3 steps, because if we want to increase it, for example, if we need to enlarge it 2 times before it is 3's, we want to enlarge it 2 times, it will become 6's. How should we do? We should press Control A, Control C, and Control V. So it is the 3 steps. Now we are going to check how can we increase our DP array. So the DP, this is the DPI. DPI is here. How can we increase it? If we choose, for example, if our DPI equals to 7, so 7 is here. So how can we increase it? Maybe, we can press from other places. For example, we can press from here, from the first place index with 0. So this is I gonna check the first position, to see if I can increase my final result of DP7. So for this one, how can I increase it? So maybe I can choose from 0. So for 0 is for j equal to 0. If j equals to 0, j means my starting point to use the Control A, Control C, and Control V solution. If I use this Control press solution, it means I'm gonna start from here, and then I'm gonna to use this solution to see if I can get the maximum value or not. Let's try. So from here, I'm gonna to use. So this is my DPJ. So at here, I'm gonna first use a Control A. I goes here, index 1, and then I press Control C. I get what? I goes to index 2, and from here I can press Control V. So what I get, before I have a 0 is, if I press it, if I press the Control V, I still have a 0 because I have nothing. And if I want to paste it, I still paste nothing. So here will still be 0, right? And then from here, I still press Control V, it will still be 0, 0, and 0 until here. So the final result will be 0. If I gonna start from, for example, from here, from dpj equals to 1, for example. Let me make it smaller. If the index will start from 1, let's see what's gonna happen. So the interesting thing gonna happen, let's check. So if this index j start from 1, it means we already have a value of 1. And from 1, we're gonna choose press Control C and Control A and Control C. So from here, we're gonna press Control C, it goes to index 2, and Control C goes to index 3. After that, we're gonna press Control V. So from here, after press Control V, we have a value of 2, right? Because before it is 1, after copy it will be 2, and then after paste, I gotta have a 2, and then I still press Control V. I will have a 3 and 4 and 5. So this means if I start from index 1, I gotta have a final result of 5. But 5 is not more than 7. It means not the maximum. So what about if I try to start from index 2? If j equal to index 2, now I'm going to check. At index 2 for the dpj, I have a value of 2. Now I'm gonna press Control C and Control A and Control C. So Control A goes here, Control C goes here, and then I'm gonna press Control V. If I press Control V here, before it is 2, now it becomes 4. And I will continue to press the Control V and Control V, it becomes 6 and 8. So it means if j equals to 2, my final result will be 8. But 8 is still not the maximum, because of the maximum of 9. Let's try another one. If we try to start from j equals to 3, if j equals to 3, so it's gonna be here. And then I'm gonna press from here to press Control A and Control C. After that, I'm gonna press Control V. I'm gonna have a 6. Yeah, because 3 plus 3 is 6. And now I'm gonna press the last step. It is a Control V. 6 plus 3 is gonna be 9. So for z equal to 3, I'm gonna have a value of 9. Now I'm gonna try to the last one. For z equal to 4, if z equal to 4, I'm here. It's a value of 4. Now Control A, Control C, and Control V, I have a value of 8. And I cannot press anymore because it's out of the range. Yeah. Now, what is the maximum value? So the maximum value is 9. So we're gonna return a 9. Yeah. So this is basically the DP solution for solving the problem. So for our solution, we're gonna start for the I. Actually, the I can start from 6, but it doesn't matter. We're gonna start the I from 3. So the I for the dpi will start from index 3, but for the dpz will start from 0 to what? To this I minus 3. Yeah, because we're gonna consume this Control A and Control C. For example, if I start for for this index I is I'm gonna start from index 3. So what about z? So z gonna start from the index 0. Why? Because for 0 at this place, I gonna consume a Control A and Control C, and then I gonna use a Control V. I gonna increase my value. Yeah. So this is why I gonna start from I minus 3. So this means z will start from 0 to I minus 3. Yeah, included. And this 3 is also included because I will consume this Control A and Control C. Yeah, if I start from 1, for example, so the z will still be, the I will still be 3. So if this z pointer will start from 1, what's gonna happen? I'm gonna use a Control A goes to 2 and Control V goes to here. I still didn't increase the value, so that is why. Yeah, because if I go to the next step, I go out of the range. So for the z, it always be 3 places before this I. So because I will use Control A and Control C. Yeah, and what is my final result? So it is just some math calculations. Yeah, so for example, before my result is dp z. Yeah, so for example, let's try to use this example. So I'm gonna use this example. Z equals to 3 and the maximum value is 9. Yeah. So for this one, so z equals to 3, z is here. Yeah. And my I is at 7, right? Yeah, because I'm gonna calculate the dp7, this value. So I'm gonna calculate the dp7, but my z is at the 3 place. So how can I calculate it? Yeah, actually I repeated it before, like from here we're gonna plus 2 plus 3 plus 3, but exactly how should we calculate? So the dpz should times, because dpz is 3, should times what? Should times I minus z minus 2y, because this is 7 minus this z 3. But for this 4 and 5, I still consumed a Control A and Control C. So this is why I need to minus a 2. Yeah. So this I minus Z and minus 2 is how many steps, how many copies I need, how many paste. So this Control V, how many paste I need. But finally, I should also to plus the previous value before, because previous value I still have a dpz. So that is why I need 2 plus 1. Yeah, let me explain again. So for the value accumulated, for the dpz, it is a dp. For example, dp3 it is here, and I'm gonna to check my dp7. So the dp7 should equal to this dp3, and this I is 7 minus 3 minus 2. It is 7 minus 3 is 4. 4 minus 2, it is 2, plus 1, it is 3. So the dpz equal to 3. 3 times 3, it is 9. Yeah, because this 1 means we already have a 3. This I minus j minus 2, it means how many paste we used. Because this 4 and 5, we need to minus this 2, because this 2 means didn't do anything, just for preparations. Yeah, this is I minus j. Yeah, for I minus j and minus 2. Yeah, let me, yeah, so this I is 7. 7 minus this j, 3, it is 4. And we still need to minus a 2. Yeah, because this 4 and 5, we don't need it. Yeah, because from 3 to 7, actually, if we can always paste, we can from paste 4 times, 4, 5, 6, and 7. Yeah, right. This is just j minus I. And this 4 and 5 didn't do anything, so we need to minus 2. But we need to also plus the previous value before. This is 3, so it means we need to plus 1. So this is the updating for the DPI. Now let me go to the code editor to code it up. Yeah, and you can check that with my explanation and with my coding. Only after that, you're gonna understand why the DP solution works. But before that, let me prepare some other examples. Yeah, maybe we can use this example, dp7 equals to 9. If we continue use this step, still use a control V. So what about f8? So the f8 gonna be 12, because 9 plus 3 is gonna be 12. And what about f9? Yeah, we're still gonna plus 3, so it's gonna be 15. And what about f10? f10 will be 18. So this is what we're gonna use. If we still use the from f7 here, we're gonna still use the control V, we're still gonna paste, so it will become 12, 15, and 18. But what if we choose another solution? From here, we're gonna use a control A, control C, and control V. So it means from F8 and F9, it's still be 9, but F10 will be what? F10 will be 18. Yeah, let's check what's gonna happen after that. So F11, if we still choose our second method, so from here we're gonna use the control A, control C, and control V. So F11 should be what? We're gonna plus a 9. It will be 27. Yeah, but if we use the previous method here, F7 gonna be 21. Yeah, as you can see, 27 is more than 21. So this means the DP solution will always work. This means we're gonna check all the combinations. So this also means the greedy solution didn't work. Yeah, it doesn't mean from some place you find a place and then you're gonna use the greedy to times this value. But it is from some place, maybe here you're gonna use greedy, maybe here inside you still need to plus some a's, and then you still gonna use control A, control C, control V, because you don't know it. This is why the DP works. The greedy didn't work. Yeah, because it can be from other places you're gonna press some a's, and then you're gonna still use the control A, control C, control V. Yeah, so you never know from which place it's the maximum. You have to check, look through the array to check one by one to check which one is the maximum. Yeah, now let me code it up from here. As I explained earlier, I'm gonna use a DP array. So the DP array will be start from 0 for I'm going to use a DP arrays preparing for the plus A solutions. So I for I in range n plus 1. So this is only for press A's. If I press A, it means DPI is my final result. If DP7, it's gonna be 7. So this is just for the first solution. Yeah, for press A's. If I can press others, I'm gonna check if I can get a maximum result. Now I'm going to loop through the I. So for I in range, I'm going to start from 3. Actually, you can start from 4 or 6. You can still get the right result. But I'm going to start from 3 just to make it consistent with my explanation. And this is I. And for J, I'm going to, for the J should be starting from 0, and it should be I minus 3, right? Because here I equals to 3, so it should be I minus 3. But for the Python, I minus 2 is not included. Actually, it is started from I minus 3, right? Yep. So this is why I use I minus 2. Actually, the maximum for J is I minus 3. Now, I'm going to update my DPI. So the DPI should be maximum of DPI with my formula. So the formula is dpj times, as I explained earlier, it should be ji minus j plus 2 minus 2. It is because there are two control A and control C. We didn't do anything, so we don't need to. We have to minus 2, and then we need 2 plus 1. This one means the dpj before. Yeah, actually this is the final code basically. And then I'm going to return the dp minus 1. Yeah, let's just run it to check if it works. It is just 4 lines of code, but you need to think about a lot of combinations. It's a difficult problem, even it only has 4 lines of code, I have to say. As you can see, it works, and it's pretty fast. Let's just check the time complexity. So the time complexity is n times what? N times n, because this I, if this I equal to n, this I minus 2 is still be n, and then we'll check all the situations. And n is 50, it means it's gonna be very fast. And the space complexity is just on. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. See you next time.